What's going on, everyone? Welcome to Moonbuilt Garage, and welcome to part 3 of my budget DIY CNC plasma table build. Well, I got the prototype Y-axis working. Don't mind that noise, it's a spring rubbing. Let me show you where I'm at, how I got here, and my plans for going forward. So my original plan for the Y-axis or the X-axis support, gantry support, this piece right here, this red plate, whatever you want to call it, was to use 1/4" aluminum. So I made a run to my local scrapyard, and of course their aluminum gets picked over pretty quick. But what I ended up with was this 1/4" fiberglass board. Now this stuff has actually been really nice to work with. I mean, it cuts real well. It's pretty stable as far as flexibility and twisting and everything. Couple things to keep in mind though when working with it. First, it will go through saw blades quick. I tried cutting out some of the curves for some cams with a skill saw, and it just chews those blades up. So I end up doing a lot of my cuts on my portaband or just using circular saw. Second thing to keep in mind is when sanding it, especially when sanding it, but when cutting it, drilling it, sanding it, wear a mask. The dust that this stuff kicks up, that stuff will mess you up. And for the cost, it can't be beat. I mean, I paid for a nearly 4 foot by 5 foot section. It cost me 25 bucks. So for the two pieces that I have used up right here, I'm maybe $2.50 in supplies. And for a budget project, that's not bad. And my original plan was to kind of prototype this whole thing out of 1/4" MDF, but for the cost, this stuff hasn't been bad to work with. And seeing how this goes, I may just run these as is. I may not go with another material. We'll see, but you know, plans always change. So like I said, this is basically a prototype, version 1 of my prototype for the gantry. It rolls really well, but I've already identified some changes that I'd like to make. So let me set you up on a tripod and I'll show you some of the improvements that I want to make to this already. So the first thing I had to consider was the height of my X-axis. I didn't know how high I should have this above the table. Doing some research, I mean, I'm seeing everything. Guys are putting their X-axis, 2, 4, 6, 10 inches above their cut surface. So there's really no right answer. I knew I wanted mine as low as possible to the cut surface just for center of gravity. It obviously keeps the weight down, keeps it more stable. But I didn't want to limit myself in my table clearance. What if I wanted to cut like a notch in some 4x4 tubing? So what I did was I made the rails taller, added these mounting holes, and now I can move my entire X-axis up and down based on whatever I'm working on. It's honestly probably going to live right here most of the time, but I wanted that flexibility. Second, I didn't know just how far back my X-axis needed to go in order for my torch head to be able to have full access of my cut surface, to come all the way to the back of my cut surface. I had to wait for my X and Z axis mount to get here. Then I could, this is going to ride across the front, and that allowed me to then make my measurements. And what I found was that I have about 2.25 or 2.5 inches of extra space behind this rear edge here to the back of the frame, which is great because the way that I put this together right now with the rail being right at the back of this plate, it actually sits just behind this roller, which I could move it back a little bit, but what it does is because of the weight up here, it makes it tip real easy. So it's not very stable right now. But like I said, that's fine. I'm going to extend this base back by 2 inches, and that'll then put this rail between the rollers and make this a lot more stable. All right, third, my rollers. So the weight of the gantry really only rides on those 2 top rollers. But I needed a way to obviously secure the rail, or secure the rollers to the rail. So on the bottom here, there are 2 more rollers, one in the back, one in the front, and they're on these cams that are attached with springs that allow this to pull this up and secure it to the bottom of my rail. Let me take this apart and I'll show you exactly what I'm talking about. All right, so here you can see a little bit better what's going on. Here are my 2 top rollers that ride on top of the rail, and those are what support the weight of the gantry. My 2 bottom rollers are mounted to these 2 cams that are on pivots, and then they're tied together with this spring. And what that does is that spring then applies upward pressure to the rollers, thereby locking these 2 rollers to the bottom of the rail. All right, so there you can see now how that lower spring applies that upward pressure to that bottom roller and keeps everything locked in place. Now, I wish I could take credit for that design, but I actually saw that on another YouTube channel, a year ago, 9 months ago, when I really started thinking about building this table. I came across that design idea and decided I really liked it, so I wanted to incorporate it here. I did change the cam design a little bit just for some better leverage, I think. If I'm able to find it, I'll leave a link to the video, or at least to the channel, down below. I'll try to find it. I really want to give credit where credit's due. So as you can see, I mean, even between these 2, there have been a bunch of iterations of the cam design, the layout, mounting holes. I mean, this one though, I think is going to be the one that I'm going to go with for now. This one definitely seems to work the best, so that's what I'm sticking with. All right, so I'm really at the point now where I need to get version 2 of my Y rollers, or my gantry support, completed. Mainly, like I said, I got to widen the base 2 inches, and that's for the overall stability. And there are a few other little minor tweaks I'm going to make. But before I can really continue forward with anything else on that table, these have to be dialed in more. So that's what I'm going to be working on right now. So I'm going to blow these 2 apart, use them as a template to kind of start laying out version 2. Now, like I said, I have been doing all of my drawings and layout and everything in CAD, but I've been transferring all of this as I've made changes and as I've added things. I've been transferring all of these into a Fusion 360 diagram. I'm just teaching myself Fusion 360, so I figured this is a good project to start learning that. So as I've been making changes, I've been tweaking my drawings in Fusion to eventually, maybe, hopefully, make these side pieces out of metal, probably aluminum. We'll see. But at least by having an updated drawing in Fusion, I don't have to worry about throwing out my CAD design. Let's get to work. All right, so you saw that I had the two boards screwed together, and then I sanded down all the edges with the boards screwed together so everything matches. Now, the shape, it's not critical. What is critical are my layout lines and all of my hole locations. So once I got everything sanded down and with the board still screwed together, I took it over to the drill press and let's show that, drilled out all the holes. So everything should line up to get all the hardware bolted back on and get it back on the plasma table. I just realized I hadn't touched on the hardware yet. So you saw the V-groove bearings in the last video. So what I did was I got these threaded inserts. These are just weld nuts with a 3/8 diameter shank that fits the V-groove or the V-bearing perfectly. And then I had to make these 1/4 inch spacers. I made it out of the same material, cut it down, just drilled the hole, sanded it down so that it would fit inside the groove of the bearing there so it doesn't interfere with the outside. Otherwise, if I just bolted this directly to the plate without a spacer, the bearing wouldn't turn. It would rub on that surface. Also, I had to, because of the cams, I had to account for that at the same time. So I had to make sure that this bearing would be spaced out the same distance as this bearing when taking the cam into consideration. Also, I have in there some real thin nylon washers. Again, I had to use those just to space things out. You can see one there, so that everything would turn while rubbing up against the side, while rubbing up against the bearing. You see there's a nylon washer in there also. So that was just something I had to kind of plan and figure out was the spacing needed. Eventually I'm probably going to make these out of some Delrin that I have laying around, just so they might slide easier. But these have been working out pretty good. These spacers don't really turn. It's just to space the bearing out. It actually turns on that nylon washer. So everything seems to be moving around really well. So I may make them out of Delrin. Same with the cams. Once I get the cam design figured out, I may make it out of Delrin. I'm not sure if that might be more durable than this material. It remains to be seen. But for now, these will work out just fine. All right, let's bolt everything up. Now I'm just spacing the bolt out with a couple of washers. Otherwise, the bolt will protrude too far through the weld nut and it could rub. I'm just making sure that it doesn't protrude through the weld nut. That's all those spacers are really for. So on the cams, I actually drilled that 3/8 hole out to 25/64 just to make it a little bit easier to get that cam through there, or to get that weld nut through the cam. I should probably do the same here. I marked it as 3/8 hole. I should probably drill that out to a 25/64 though, just to make it a little bit easier to assemble. But for now, that's what a hammer's for. Or in this case, a dead blow mallet. No. We can take that over to the drill press and drill those out to 25/64, I think. Yeah. There we go. Of course, now my spring probably isn't going to be long enough. I may need to go find some longer springs. And with everything bolted back together, this thing rides real nice. That high-pitched noise, that's the spring that tensions the cams. That's rubbing on the side rail. Yeah, I'm going to have to fix that. That'll drive me nuts. But stability, it no longer wants to tip backwards. I mean, now that these rear rollers are behind the x-axis, there's no more, very little does it want to tip. I think that's just the way it's sitting on there. There is a little bit of racking, but that'll be taken care of once the drive motors are installed and all that's dialed in. They'll be working in sync, and that won't rack. I will be adding physical stops to the ends of the rails, top and bottom, front and back. There's going to be electrical stops, electrical sensors for stops, but I want the physical stops also, just to be on the safe side. The x-axis rail here is 0.15 degrees difference in level this way compared to the frame. So for a plasma cutter with a torch height control, that is not even gonna matter. Cost. So at the end of last video, I was at $238.15. So figuring in the costs of the V bearings, which those go for about $369 each, got 8 of them, that's $29.50 in V groove bearings. Weld nuts, what I used as pivots for the bearings and everything, or as the axle for the bearings and the pivots for the cams, those are about 79 cents each for a total of $632. Miscellaneous hardware comes out to a few bucks, 12 about or so. The fiberglass board. So like I said, I bought a 4x5 roughly size sheet, and I had done the math. I have it somewhere. I don't know what I did with it. The side pieces that were on here at the beginning of the video was a grand total of like $2.50. So I figure with these being a little bit bigger, I have $6 total in my side rails, both version 1 and version 2 combined, about $6. So that gives me a total of, today in this video, about $53.08. So grand total for 3 days of $291.23. It's not too bad. Next video, I will be working on probably the Y-axis motor mounts. I'm going to be using NEMA 23 motors, so I'm going to be figuring out exactly how I want to mount those and the drive system to drive this forward and back. Now, I don't have the control unit yet, power supply, anything like that. That stuff's going to add to the cost quick. But I'll be able to at least get the motors in and the drive system figured out and in place, hopefully. That should be the next video. Appreciate you guys for watching. Hit that subscribe, hit the bell, and I'll see you on the next one.